All right, so let's start with some questions. Find the exact value of cosec 240 degree. Now, what is cosec? Cosec is the reciprocal of sine or cos?
Sine.
Sine. So cosec is a reciprocal of sine, so 1 upon sine of 240 degree. If you remember 240 degree, where will 240 degree lie? In which quadrant?
Um, tan.
Do you agree that it is going to lie in the third quadrant?
Yes, the third one.
I think my screen is lagging again.
Yeah.
Just a second. Okay, can you hear me?
Yes, I can hear you.
All right. Now the screen is fine. So 240 degree angle is in the third quadrant. If I ask you what is the basic angle, what would you say?
240 degrees. 180 minus 240.
60 degree?
60? Yeah.
Yeah. So sine of 240 is going to be equal to sine of 60 degree. But the problem is that in the third quadrant, sine is negative, right? In the third quadrant, the sine is negative. So what is sine 60 degree?
Um, it's
Root
root
3
3
upon
upon
2.
2.
So the final answer is going to be minus 2 over root 3. Okay?
So I don't understand why 60 is the basic angle.
60 is a basic angle is the acute angle. This is 240 degree. Basic angle is the angle that the line will make with the x-axis. The acute angle that the line makes with the x-axis is 240 minus 180, that is 60 degree.
Okay.
Okay. I'm going to share my screen again because फिर से lag आ रहा है. Okay, now it's fine, right? Yeah. All right, shall I move on?
Yes, sir.
Okay. Solve secant square x minus 10x minus 3 equals to 0 for x is greater than equal to 0 degrees less than equal to 360 degrees. This is a trig equation that has secant square over here. So do you remember the identity that is going to help us remove secant square x? That day we did one identity which
Yeah,
says
sir.
1
Um,
plus 10 square is secant square.
yeah.
So in this equation, if I want to solve this trigonometric equation, I should have one trigonometric ratio. So I can replace secant square x by 1 plus 10 square x. So 1 plus 10 square x in place of secant square x minus 10x minus 3 equals to 0. 10 square x minus 10x minus 2 equals to 0. Now, what form of the equation is this? Does this look like a disguised quadratic equation?
Yes.
So if I say, okay, let y equals to 10x, then this is going to be y squared minus y minus 2 equals to 0. And if I factorize this equation, I can
Y
get,
minus 2 and y plus 1.
yes, it's going to be plus 2 and minus 1.
Yeah.
So 10x is going to be 2 and 10x is going to be equal to negative 1. Now let's find the angles. We want the angles from 0 to 360 degree. So you need, so how am I going to solve 10x equals to 2? 10x is equal to positive 2. So 10x is positive in the first and the third quadrant. I'll
Yeah.
find the basic angle first by taking 10 inverse of 2. 10 inverse of 2 comes out to be
63.43.
63.43. So 63.4. So one value of x is going to be 63.4 and the other value is going to be 180 plus 63.4, which is
243.4.
243.4. These are the two angles. Now from 10x equals to negative 1, 10x is negative in the second and the fourth quadrant. These are going to be my basic angle. To find the basic angle first, I'm going to take 10 inverse of 1 without the negative sign. So that's going to give you 45 degree. So the first angle is going to be 180 minus 45 and the next angle is going to be
135 and 315.
350. Yeah. So these are the solution to this equation secant squared x minus 10x minus 3 equals to 0. 63.4, 135, 243.4 and 315. Okay.
Okay.
All right. Now the next thing that we are going to start is the concept of compound angles. Compound angle formula. We are going to see a few formulas. Compound angle formula. Compound angle means that if we are to find a trigonometric ratio of two angles ka sum, let's say A and B are the two angles, and when you add them together, it is going to result in a new angle, and you are being asked to find the trigonometric ratio of this angle, the compound angle. A plus B is the compound value of A and B. So if you are asked to find sine of A plus B, sine of A plus B is always going to be equal to the product of sine A cos B plus cos A sine B. Now, in our syllabus only tells us to remember these formulas. Sine of A plus B is always going to be equal to sine of the first angle times cosine the second angle plus cosine of the first angle times sine of the second angle. So it's better to remember in this way: sine of A plus B is equal to sine A cos B plus cos A sine B. Now, if this would have been A minus B, then the only difference would be sine A cos B minus sine A minus cos A sine B. Okay, that's the first. The next formula is for the cos of a compound angle A plus B. Now, the cos of a compound angle is cos A cos B minus sine A sine B. Now, in cos, there are going to be the opposite sign. अगर यहाँ left side पे you're getting a plus, then there is going to be a minus. So cos of A plus B is going to be equal to cos A cos B minus sin A sin B. And if this would have been cos A minus B, then this would be cos A cos B plus sin A sin B. All right.
Yes, sir.
Now the third is the tan, tan of the compound angle A plus B. Tan of A plus B is equal to tan A plus tan B over 1 minus the product of tan A, tan B. So if you have a plus sign over here, the numerator is going to be of the same sign, plus, and the denominator mein there is going to be a negative sign. So tan of A plus B is going to be equal to tan A plus tan B over 1 minus tan A tan B. Now, if this would be minus tan of A minus B, then the result is going to be equal to tan A minus tan B over 1 plus tan A tan B. That is the only difference. So actually there were 6 formula to remember, but I have summarized them into 3 formulas. Let me show you an example. Sine of 105 degree, we are being asked to find the exact value of sine of 105. Okay, exact value of sine of 105 degree. Now 105, I need to recall how can I split 105 degree angle into two such angles जिसका trigonometric ratio मैं easily find कर सकता हूँ. So 105 is the sum of 60 plus 45. Can I say that?
Yes, sir.
Now applying the compound angle formula, sine of A, which is 60, plus B, which is 45. Sine of 60 plus 45, उसमें फिर हम ये वाला फॉर्मूला यूज करेंगे. Sin A plus B is equal to sin A cos B plus cos A sin B. So using this formula, let's solve this further. Sine of, how am I going to solve this? Formula that,
Sine is 60 times cos of 45,
yes.
which is root 6
So
upon 4.
प्लस आगे पहले बता दें. साइन ऑफ 60 cos 45 प्लस
Um,
cos of 60 sin of 45.
yeah.
Now sin of 60 times cos of, sin of 60 is root 3 upon 2. Cos of 45 is 1 upon root 2. कैलकुलेटर से अगर करेंगे तो रूट 2 अपॉन 2 भी आ जाएगा. इट्स द सेम थिंग. Cos 60 is 1 upon 2 and sin 45 is again 1 over root 2. So if we solve this, what is the final answer that we get? This is root 3 upon 2 root 2. and this is 1 upon 2 root 2. So if you add that by taking making the denominators common, this is going to be root 3 plus 1 over 2 root 2, right?
Yeah.
Do you need time to copy anything down?
Oh, yes, I'm copying the formula.
Okay.
Also, I have it down. You can change the screen.
All right. Cos of 42 cos of 12 plus sine of 42 times sine of 12. Now this, if you recall this, this is in the form of cos A cos B plus sine A sine B, where A is 42 and B is 12. So how can I, this is the expanded form of a compound angle. So what is the compound angle over here? Which trigonometric ratio will it be?
Cos A plus B.
Cos A
Cos
plus
A
B.
minus B.
Yes, so cos of 42 plus 12, which is,
0.588.
acha, there is a small mistake. This is
It's
going to
cos
be
A
cos
minus
A
B.
minus B, yes. Cos A minus B, so 42 minus 12, 30,
Is root 3 upon 2.
root 3 upon 2. So the overall answer for this is going to be root 3 upon 2. All right. Now, given that sine of A is equals to 4 upon 5 and cos of B is equals to 5 over 13, where A is the obtuse angle and B is acute. Find the value, find the value of number A, sine of A plus B. So we need to find the value of sine of A plus B. B is acute angle, so we don't need to worry about that, but A is obtuse angle. Achha, if A is obtuse angle, in which quadrant will that be, the angle A is going to lie?
Second.
second.
So the sign will be this positive, right? Because it's just
Sine of A is still going to be positive because in the second quadrant sine is positive. So 4, 5, and if I just use Pythagoras theorem, that is going to be negative 3 over here. Okay, the length is going to be 3, but I know it's a negative x-axis. This is angle A, and angle B is acute, so it's going to be in the first quadrant. 5 over 13, so this is going to be 12. This is angle B. Now, they want us to evaluate sine of A plus B. Sine of A plus B की expansion क्या होगी? Sin A cos B plus cos A sin B. So what is sine of A?
uh sine of 4/5,
4 upon 5. What is cos of B?
5/13
5 upon 13. Now what is cos of angle A?
will be 1 minus 5/13.
It is going to be minus 3 upon 5. Cos is a ratio of adjacent over hypotenuse. So
Oh, okay.
minus 3 over 5. And what is sine B going to be equal to?
5/13.
5 upon 13. Right. Okay, now you can solve this. What is the final answer?
I think it's 1/13.
Oh, final answer.
So I think so. Let me just recheck.
Hmm.
Yeah, so 1/13.
1 upon 13. Okay. Let me just cross check that. Okay, let's move on to the next part. Cos of A minus B. And the third part is tan of A minus B. Okay, you can try them. It's the same question. Do you want me to keep the screen over here or on or over here?
So over.
You can copy down this first, and then I
Oh,
can change the screen to that.
okay, so I have it down. Sir, I've gotten cos and both the parts as answer, but I think the second one is wrong.
Let's find out. So cos A minus B is equal to cos A cos B plus sine A sine B. Cos of A is going to be minus 3 upon 5. Cos of B is going to be 12 over 30. Sine of A is 4 over 5 and sine of B is simply 5 over 30. If we solve this, what do we get?
1 over 13.
Minus 12 times 3 minus 36 over 5 times 13 is 65 plus 20 times 65, 20 over 65. So minus 36 plus 20 is going to give you minus 16 upon 65.
I have the wrong thing written for cos B.
Cos B is 5. Oh, okay. It's my fault. Actually, I copied down the question now. You
Okay.
see, cos of B, here is my mistake. Cos of B is 5 over 13, which means 5 is the adjacent, 5 should be the adjacent, and 12 should be the opposite side. Make sense?
Yes, sir.
Now, if I solve the first part, sine of A plus B, sine of A is fine, cos of B is going to be 5 over 13 plus cos A is minus 3 over 5 and sine B is going to be 12 over 30. So if I resolve this question, I should get 20 minus 12, 20 minus 36. It's going to be minus 16 over 65 for this part. Okay. Yeah.
Yes, sir.
For the next part, cos B was 5 over 13. So I'm going to replace this with 5 over 13. And sine B is 12 over 13. So let me calculate this all over again. Negative 15 over 65. Negative 15 over 65 plus 48 over 65. 33 upon 65. Are you getting the same answer now?
Yes, sir.
Tan of A minus B is going to be equal to tan A minus tan B over 1 plus tan A tan B. Tangent of A is going to be 4 upon minus 3. So negative 4 upon 3. Tangent of B is going to be 12 upon 13. Sorry, 12 upon 5. Yeah, 1 minus over 1 plus tan A tan B. So we need to solve this further. Please check if you're getting this.
Oh, so why wouldn't it be 5/12, not 12/5?
See, tan theta is a ratio of opposite over adjacent. So over here, the opposite length is 12 and the adjacent length is 5.
Yeah.
So 12 over 5.
Okay.
ठीक है, should I move on?
Yes, sir.
Solve the equation sine of 60 minus x equals to 2 sine x for x greater than 0 and less than 360 degree. So in this question, there's an involvement of a compound angle. Sine 60 minus x is equal to 2 sine x. So the first thing that should come to your mind is to expand using the compound angle formula. Sine of 60 minus x is going to be sine of 60 cos of x minus cos of 60 sine of x, right? Equals to 2 sine x. Now sine 60 is root 3 upon 2 and cos 60 is 1 upon 2. Now from here I want you to solve. Simplify the equation. You're going to end up with cos x term on the left side of the equation, sin x term on the right hand side of the equation. Then you can divide sin x by cos x and rearrange to find tan x.
Okay. So I'm really not sure what to do.
Okay, let me help you. So if you take minus half sine x on the other side, you're going to get 5 upon 2 sine x. 2 plus half is 2.5, which is 5 upon 2. And on the left hand side, you are going to have root 3 upon 2 cos x, right? You can simplify this 2 and 2. So this is going to be root 3 cos x equals to 5 sin x. Now I was asking you to divide sin x by cos x and divide root 3 by 5. Do you remember what is sin x over cos x?
Tan X.
Tan x. So basically now we can only solve an equation with the one trigonometric ratios. Tan x is root 3 upon 5. You just have to solve this equation for the values of x.
Oh, okay. 19.1.
Yes, and what's the other angle? 19.1 and
I'm only getting 19.1.
uh, basically we are going to solve this for the domain of 0 to 360.
Oh,
10x is positive in the first and the third quadrant. So what you have right now is the acute angle.
199.1.
199.1. So these are our two angles. Any questions so far?
No, sir.
Okay. So you're clear on applying the concept of compound angle, right?
Yes.
Now, extending the concept of the compound angle further, we are going to discuss the double angle formula. Double angle formulas are derived from the compound angle formula. So I'm going to write the first, that is sine of A plus B, and we said that this is equal to sine A cos B plus cos A sine B. Now, when we say double angle means that A and B are same. So, if A is equals to B, or I'm going to write B equals to A, I mean, the angles are same. So, A plus A, sine of A plus A is just going to be sine of 2A, right? Sine of A plus A is going to be equal to sine of A times cos of A plus cos of A times sine of A. Would you agree with this? If A and B were equal.
Yeah.
So I can reduce this formula down to sine of A plus A is going to be sine of 2A. And that is equal to sine A cos A plus cos A sine A. So it's the same value. So you can write 2 sine A cos A. Sine A cos A plus cos A sine A, it's just 2 sine A cos A. So this is the double angle formula for sine. Sine of 2A is going to be equal to 2 sine A cos A. Just give me a second. I need to answer the doorbell.
Okay.
All right. So sine of 2a comes out to be equal to 2 sine a cos a. That is the first double angle formula that you are going to remember. Then moving on to cos a plus b. Cos a plus b was equals to cos a sine b, sorry, cos a cos b minus sine a sine b. Cos a cos b minus sine a sine b. If we had a positive sign over here, on the right hand side we had a negative sign. Now if the angles were same, if b was equal to a, then this is going to become cos a plus a, and wherever I have b, I'm going to replace it with a, cos a minus sine a sine a. So cos a into cos a is cos square a, sine a into sine a is sine square a. So cos of 2a, cos of this double angle 2a comes out to be equal to cos square a minus sine square a. Is this clear?
Yes, sir.
Now, cos 2a can be represented in multiple ways. If you remember the identity, I can replace cos square a with 1 minus sine square a. And I already have minus sine square a over here. So the end result is going to be 1 minus 2 sine square a. That's also the double angle formula. That can also be the double angle formula for cos 2a. And the other way of expressing this is going to be कि आप sin square a को replace कर लो. So if I replace sin square a with 1 minus cos square a, then cos 2a is going to be equal to cos square a minus 1 minus cos square a, which is going to be 2 cos square a minus 1. So there are three ways of writing cos 2a. Now it is always going to depend on the question कि which form would you want to prefer. Acha. Also, if you simplify this, cos square a minus sin square a is in the form of a square minus b square. So if you want to factorize it further, you can write cos a plus sin a times cos a minus sin a. ऐसे भी लिख सकते हैं. Okay? Let me
Yes,
know
sir.
if you want me to repeat any of the thing.
No, I got it.
Okay. Should I move on to 10a or do you want to copy down this first?
So you can move on to Tani.
Okay. You have noted down?
So I'm gonna look at the recording later.
अच्छा ठीक है. So the next is the double angle identity for tan. So tan A plus B was equals to tan of A plus tan of B over 1 minus tan A tan B. Now Michelle, if B was equals to A, then what would be written on the left hand side?
Tan A plus A or tan 2A.
Tan 2A. Okay. And on the right hand side, I'm going to replace tan B with tan A. So if I simplify this, I'm going to get tan of 2a is equals to 2 tan a. Tan a plus tan a is 2 tan a over 1 minus tan square a. So tan 2a can be written as 2 tan a over 1 minus tan square a. So these three formula are known as the double angle formula. Shall we move on to the questions now?
Okay.
Given that sine x is equal to negative 3 upon 5 and that x is greater than 180 less than 270, find the exact value of sine of 2x. Given that sin x is negative 3 upon 5 and x is between 180 and 270. So where is the angle x being made? In the first, second, third or fourth?
Third.
In the third quadrant, yes. Also, if you are going to use, this is 2x is a double angle. So sine of 2x is going to be equal to 2 sine x cos x. Now I know that the angle is being made in the third quadrant. This is x. Sine of x is negative 3 upon 5, and we all know that in the third quadrant sine theta is negative. So negative 3, 5. If you use Pythagoras theorem, you are going to get this as 4. The adjacent is going to be negative 4. So in the third quadrant, sine of x is negative 3 upon 5. What is cos of x going to be equal to?
Minus uh
Minus 4
minus
over
5.
5, and tan of x is going to be equal to
Minus 3 over 3 over 4.
minus 3 over minus 4 is going to be equal to 3 upon 4. So these are the trigonometric ratios that we are going to use. So sine 2x is equal to 2 sine x cos x. So 2 times sine x, which is negative 3 upon 5, times cos x, which is negative 4 upon 5. So are we getting 24 over 25 now for the first part?
Yes,
Okay, now I want you to solve these for me. Cos 2x, and then we are going to solve tan x upon 2. So what is the double angle formula for cos 2x?
so could you go back? 2 cos square a minus 1.
Either I can use any of the formula.
Yeah.
So if you want to use 2 cos square x minus 1, that's also correct.
Okay.
2 cos square x minus 1. Do I have the value of cos x?
Minus 4 over 5.
Minus 4 over 5 square minus 1. So what is the answer?
7 over 25.
7 over 25. Correct. Then we are going to look at 10x upon 2. Now, before we do this part, I wanted to make it clear that this is since these are the double angle formulas, which means that whatever, if the angle on the left is going to be double the angle on the right, or vice versa, you can say if the angle on on the left hand side is twice, then angle on the right side is going to be half. So if this is 2, the angle is half. Okay, so if the angle would be 4, if this angle would be 4, then over here you are going to write 2. So sine of 4a would have been equal to 2 sine 2a times cos 2a. Angle on the left should be double the angle on the right. That's the observation. So if we are asked to solve tan of x upon 2,
It will be 2 tan x upon 4 minus
but we
upon 1.
don't have anything, we don't have anything of tan x upon 4 in the question to solve. So tan of 2a is was equal to 2 tan a over 1 minus tan square a. So if I want the angle to be x upon 2, अच्छा पहले तो मैं इसको x कर देता हूँ. Tan 2x would be equal to 2 tan x over 1 minus tan square x, right? So if I want tan x upon 2, if you are saying that if I take tan x upon 2 on the left hand side, then I'll have to take tan x upon 4 on the right hand side. The
Yeah,
only problem with this is that I do not have anything to calculate for tan x over 4. How would I use the information of tan x upon 4 to calculate tan x upon 2? There isn't anything mentioned in the question about tan x upon 4. So a good observation over here would be that you take x over 2 on the right hand side. If you are taking x upon 2 on the right hand side, over here on the left hand side, what is, should it be, shouldn't it be the double of the angle? So x upon 2 ka double angle is going to be
tan x.
10x. So we do have information to calculate 10x, right?
Yes.
So on the next page I'm going to do this part. To calculate 10x upon 2, I'm going to use 10x is equals to 2 10 x over 2 over 1 minus 10 square x upon 2. Do I have the value of 10x in the question?
Yes. Mine 3 upon 4.
3 upon 4. So 3 upon 4 is equals to 2 10 x upon 2 over 1 minus 10 x over 2. I can write it like this. And over here you can, let's say, let z equals to 10 of x upon 2. Just to simplify our calculation, I'm going to replace 10x over 2 by z. So 3 upon 4 is equals to 2z over 1 minus z square. If you cross multiply this, you are going to get 3 minus 3z square equals to 8z. 3z square plus 8z minus 3 equals to 0. This is a simple quadratic equation. If you solve this, what value of z's are you going to get?
Uh, 1 over 3 and minus 3.
1 over 3 and minus 3. Okay. So that means tan of x upon 2 is equals to 1 upon 3, and tan of x upon 2 is equals to negative 3. Fine. But I need to find the value of 10x upon 2. Achha, which value would I be accepting? Should I be
1 over
accepting
3?
both values? Should I be
Um,
accepting both
I
values?
think it's only the negative one.
It's only going to be negative 3. So that's our answer. Answer.
Also, why not 1?
Okay, why not this? Because the question says that angle x is greater than 180 and less than 270. So that means it is in the third quadrant. If x was in the third quadrant, Just a second. If x, if the domain of the angle x is given in the question x greater than 180 and less than 270, then x upon 2 is going to be from 90 to 135. Would you agree with this?
Yes, sir.
Then do you agree that x upon 2 angle is in the second quadrant?
Oh, yeah.
If x upon 2 is in the second quadrant, then in the second quadrant, will the trig ratio of 10 be positive or negative?
Negative.
Negative. That's why we are only going to take negative value. That is the reason. ठीक है?
Yeah.
All right. Do you want me to wait for you to copy down this, or do you plan to note down later? Sorry.
I have it done.
Okay. Let's try one more question. Solve the equation sine 2x equals to sine x for x greater than equal to 0 less than equal to 360 degree. I want you to use the concept of the double angle and try to solve this. Okay.
Okay. So I've done a little bit, but I'm not sure.
Okay, so what's the first step?
Um, taking sine to one side.
Sorry?
I did sine 2x minus sine x.
I can also replace sine 2x. How would I expand sine 2x? Can I write 2 sine x cos x first?
Yeah,
This is the first step. Then I can take sine x on the other side. So 2 sine x cos x minus sine x equals to 0. Is there anything that I can take common out?
sine x.
Sine x. So 2 cos x minus 1 equals to 0. Since I have equals to 0 on the other side, I'm going to say sine x is equals to 0 and 2 cos x minus 1 is equals to 0. So I just need to solve the two equations separately for the values of x. So from here you can get x as 0 degree and 180 degree. And from here you can take cos inverse of 1. Cos is positive in the first and the fourth quadrant. So the first angle is going to be 60 degree and the other angle is going to be 300 degree.
Yeah.
And you can also write 360 degree over here because that value is also included. It's less than equal to. So the overall answers are going to be 0, 60, 180, 300 and 360 degree. ठीक है?
Yes.
Okay, let me write down one more question. Okay, I want you to solve this question now, but make sure your calculator is in radian mode because the angle is given in radians, so you need to make sure that the calculator is in radian.
Okay. So I'm done.
All right. So the solution would be, so which identity do you plan to go for replacing cos 2x?
So I did 2 cos square x minus 1.
If you do 2 cos square x minus 1, then you will have to replace cos square x again, right?
Yes.
Because over here we have a term in sin x. So it would have been better if you would have used this identity. Replace cos 2x with 1 minus 2 sin square x. So उससे ये होगा कि आपकी पूरी equation is going to be in terms of just one trig ratio, that is sin x.
Yeah.
Is this is Are you getting this quadratic equation?
So I got minus 2 instead of plus 1. But that's because I didn't take it as 1 minus 2 sine square x.
Yeah, but the overall equation, the last part of the equation is going to be this: 2
Yeah.
sine squared x minus 3. Just a second. Now, if you solve this quadratic equation, what are the values of sin x?
Yeah.
I'm getting 1 and 1 upon 2, right?
Yeah.
So, if I solve this by converting my calculator in the radian mode first, sin x is positive in the first and the second quadrant. Let's find the basic angle. Sine inverse of 1 is going to be pi by 2. So this is going to be pi by 2, and the other angle is going to be pi minus pi by 2, so pi by 2. That's the only angle so far from here. And when I'm solving this for the first and the second, it is going to be in the first and the second quadrant. The basic angle is going to be sine
I.
inverse of half, that is pi by 6. 30 degrees pi by 6. So one angle is going to be pi by 6. The other angle is going to be pi minus pi by 6, which is 5 pi by 6. So these are the three angles. Do you want me to repeat any of the thing?
No, sir, I got it.
You got it? Okay. So that's all for today. Inshallah, in tomorrow's
Okay.
class, I'm going to continue this further.
Okay. Thank you.
Okay. You're welcome. See you.
Love it.
Allah Hafiz.